Hello again students. So up till now we have discussed many circuits and many design strategies which were basically the manual procedure of finding the voltages or currents by using different methods. So from today we are going to start another very important series of lectures, and that is about the simulation software, or we can call it the electric circuit simulation software, which is called a multisim. So multisim is the environment which is used for simulating and checking different elements for the voltage drop and currents in the circuit, and many other purposes can also be served by using the same software. So let us first discuss the environment of this software. And first of all, we can see here that we have different options here: file option, edit option, view, and other options. So we will come back to it later on whenever we will talk about different options which will be related to these options. So first of all, let us talk about different symbols here and different elements which we are going to use. So here, first of all, when you will click over any of the option here, another box will appear here, and inside of it you can see that the database here. So I am going to use a master database. In the master database we have different groups, and inside the groups we have sources, basic, diodes, transistors, analog, and all of the options which we can use in our circuit design methodologies. Okay, so here in the sources, what are basically the elements here? So here we have power sources, signal current sources, and all of the sources which you can use in order to check or to analyze or to design any circuit. Okay, similarly in basic elements we have resistors, capacitors, inductors, and all the elements which you have to use in order to construct a circuit. So if you want to use a resistor of any value, you can click it from here, and after it you can press OK, and you will see that with the cursor I have this resistor here. So after pressing the left button of my mouse, what will happen? It will be placed here, and after it I will be back to the dialog box where I was previously. Okay, similarly in capacitors I have different values of the capacitors, inductor I have different values, transformers, and so on. If I am not going to use it further, let me press OK here, and after it, if I want to get back to the menu here, I can press the right button of my mouse, and here I can click over it. Double clicking it, what will it give me? It will give me the value of this resistor ohms. So I can change it as well. So it is by default 1k, which was written over there, so I can also write it 10. Similarly, in order to label it, I can use it. Let me use the resistor. Similarly, displaying it values, I have changed its values, and others will also be discussed whenever we will talk about it later on. The tolerance is basically the actual value up to which the resistance of a resistor can be changed, and it will be in the percentage. So all the percentage values are also given here, and up to some points I am using 0 here. Similarly, false, pins, variant, user fields, all of these values are also here. So let me press OK here. So when I will press OK, you can see here that the label resistor is here. Similarly, here I have 10 ohm resistance, and these things are used here. Okay, similarly, in order to use some other components here, I can also get back here. I can use diodes here, in which LEDs, photodiodes, Zener diodes, all the family of the diodes are also available. Transistors are available here. Similarly, microcontroller units and also advanced peripherals like keypads, LCDs, terminals, and these things are also available in order to give the input or getting the output and observing those outputs as well. Okay, similarly, miscellaneous digital and also indicators are also available. So what are basically the indicators? Indicators are basically used for the indication of the output in order to check whether the output is correct or not. Similarly, miscellaneous is also available, and all the things are also available. So if I want to use some sources here, I can also use power sources, and inside the power sources, if I want to construct a DC circuit, what I can use here, I can use the DC power here. So writing DC power here, and when I will click over here, like I will click right over here, so the DC source will be placed here. Similarly, in order to construct a circuit, what I will use here, I will also be needing a ground here. So clicking over it, I will get here this ground and it will appear here. So if I don't want to use other sources here, so let me press OK here, and after it we can see here that with the cursor I have this ground which is not removed yet. So in order to remove it, what I have to do, I have to click right here. So what will happen now, I have these components. So in order to connect them, what I have to do, I have to first get back to the terminal of my voltage source and click over it, and after it we will see that the Y type line will appear here, and after getting to the point where I want to connect it, what I will do again, I will press the right click. Okay, so what will happen, this connection will be established. Similarly, what I have to do here, again I have to get back, then here and here as well. So again this close path will be established. So in order to construct a circuit in the fully functional way, what I have to do here in the multisim, I also have to use this ground as well. So here it will give me this fully functional series circuit which is consist of basically only one resistor. Similarly, if I want to change the value of my voltage source or power source, what I can do here, I can basically click over it, writing the values here. Let me write it 10 here, and after pressing OK, what will happen now, here you can see that it is 10 volts. Okay, so this is all about the basics of my design. Similarly, what I can do here, I have some other sources like multimeter. This is a multimeter which can also be seen here, that it can also show me the current value, voltage value. Similarly, in dBs can also be seen here, and similarly resistances as well. Okay, similarly other sources are also available like functional generators, watt meter, oscilloscope and so on. So there are plenty of sources which are available here. Okay, so after constructing a circuit, I can start it from here. Okay, as the circuit is a fully functional, but I am not observing the values here. So in order to observe the values here, what I can do here, let me connect my multimeter here. Okay, so when I will connect this multimeter here, what will happen? Okay, this, let me connect it with the positive terminal and this one with this negative terminal. Okay, let me connect it, and now when I will press start here from here, or simulation switch from here, so these are basically the two similar things. So let me start it from here. When I will press it here, what will happen, the circuit is now functional, but how to observe the value of voltage drop across this resistor? Let me double click over it, and I will see that this is now in the resistance mode. So if I want to check the voltage here, I can very easily see that now it is in DC mode and it is basically 10 volts. Okay, similarly, in order to check other values here, so as the AC here is 0, so it is now giving me 0 as well. What will happen if I will press MA here? So okay, so it is giving me 0. Why is it? Because if I want to check the value of the current here, what I have to do, I have to connect this emitter in this series. So in order to find the value of the current here in this circuit, what we have to do, we have to connect this multimeter in series with this resistor. Okay, so what we have to do, first of all, let us first select this branch and let me press delete here, so it will be deleted. Okay, so now in order to connect this multimeter in series with it, what we have to do, we have to connect the positive terminal of it with the resistor, and similarly the negative terminal with this one. So now you can see that the multimeter is now in series with the resistor, and here the current which is flowing through the resistor is also flowing through this multimeter as well. Okay, so now let us simulate it, and we will see that it will show us basically 1 ampere current, because the value of current is I equal to V by R. The value of V is 10, the value of R is 10, and the ratio of these two will be 1. So the value of the current is 1 amps. So similarly, now double clicking over it, and now selecting this DC here, so I can very easily see that the value of the current is 1 amperes. Okay, so this is all about the simple series circuits in which we can construct the circuit which is composed of many resistors, and by following the same procedure we can also construct the complex circuits as well. So in our upcoming videos we will try to construct and analyze all the previous circuits which we have previously analyzed theoretically. Okay, so till then, take care of yourself, and I will see you with some more simulations, some more circuits, and some more tricks and tips which are related to the simulation of different circuits in the multisim. So after leaving it, what we have to do, let me close it, and we have to stop this simulation here. Okay, so now this is stopped, so you can now leave this circuit. So this is another lab work which is related to the multisim. So today we are going to construct a parallel circuit, and we have to see that whether that parallel circuit obeys the Kirchhoff's current law or not. Okay, so let us first go to the sources here, and in sources let me first have this DC power source. Let me put it over here. Similarly, now ground here as well, and let me put it here as well. Okay, so after it, let me have two resistors. So this is the first one, and I have to put it here. Okay, similarly another one, and let me put it here as well, because I am going to construct a parallel circuit which is going to have two branches. Okay, so now what we have to do, we have to construct a parallel circuit which is composed of a single voltage source and two resistors which will be connected in parallel with the voltage source. So what we have to do, I can also construct a circuit like that. I will be using the connections such like that these will be connected from here as well, but now in order to show it simply and for the simplicity, what I have to do, I have to rotate them. So in order to rotate them, I have to press Ctrl R here. So after pressing Ctrl R here, I can see that these will be rotated. Okay, similarly clicking over it and now again pressing Ctrl R, what will happen, these will be rotated here as well. Okay, so after it, let me connect the multimeter here. So the first multimeter here, second multimeter here, in order to observe the currents which are flowing through here. So again now rotating it, so Control R, clicking over it, and Control R here as well. Now this one, and double clicking over it, and let me have the 10 volts here as well. So it is up to you, whatever value you want it to be assigned. So clicking or OK and giving it some values like this is, let me call it or let me call it 4 ohm. So this is a 4 ohm resistor. R2 is of 4 ohm as well. So from this circuit I can very clearly tell you that the current, the total current which will be flowing through this circuit will be 5 amps, because the two circuits which will be connected in parallel will give me, these are basically the same resistances, so the equivalent resistance here will be 2 ohm. So the current, total current here will be the I equal to V divided by the resistance, which is the equivalent resistance, so 10 divided by 2 will be the 5 amps. So in order to check the input current here, I am connecting this third multimeter here as well. Okay, so now in order to connect them here as well, so the connecting it with this one with this one, and also this one here with this one. Okay, now these are in series with each other here and here. Okay, here and here. Okay, so this is basically the parallel circuit which is composed of two resistors. Now in order to complete the circuit, what I have to do, I have to connect this ground connection here as well. Okay, so what I have to do it, what I have to run it, or I can also use this simulation switch as well. So let me run it from here, and for now running it, and I will see that it will have 5 amperes of current which is flowing through this circuit. Similarly, when the 5 ampere current will flow through these two same resistors, each and every one of the resistor here will be having the half of the 5 amperes, so that would be 2.5 amps. So double clicking over it, I will get that the current which is flowing through R1 is 2.5 amps. Similarly, the current through the XM1 is also 2.5 amperes. Okay, so that is the proof that in parallel circuits what happens, that current divides. Okay, so in order to check the voltage here in these resistors, what I have to do, let me stop it, and using this multimeter here for checking the voltage here, and I will see that the voltage here will be 10 volts. Okay, so now let me run it, and after running it, I will see that the voltage across it is 10 volts. Similarly, in order to check it from, okay, so now let me first, and now delete it, and now connecting it with this point, I will see that both of these are in parallel with each other. So in parallel, voltage remains same. Running it, okay, and now pressing over it, I will see that the voltage across this resistor R1 is also 10 volts, R2 is also 10 volts, and this is also the source voltage where the two resistors are connected in parallel with it. Okay, so that's it for today, in which we have seen the characteristics of the parallel circuit, a very simple parallel circuit in which two resistors are connected in parallel with each other and with the source. So thank you so much, and I will see you with some more questions like this in our upcoming videos. Thank you.